This video is a diagram illustrating the key components of a non-independent solid axle rear suspension system commonly found in various vehicles, especially trucks, SUVs, and some older cars. This type of suspension means that the wheels on either side of the axle are connected and move together, unlike independent suspension where each wheel can move vertically on its own. Here's a detailed description of the labeled parts. Spring, coil spring. Location, one on each side, mounted vertically between the vehicle's chassis, not explicitly shown but implied above, and the solid axle assembly. Function, springs are the primary component for supporting the vehicle's weight and absorbing road impacts. When a wheel encounters a bump, the spring compresses, storing energy, and then expands, releasing that energy to help the wheel return to its original position. In this diagram, coil springs are shown, but leaf springs are also common in solid axle setups. Shock absorber. Location, one on each side, typically mounted parallel to or slightly angled relative to the springs, also connecting the chassis to the axle. Function, while springs absorb bumps, shock absorbers, also called dampers, dampen the oscillations of the springs. Without them, the vehicle would bounce excessively after hitting a bump. Shock absorbers convert the kinetic energy of suspension movement into heat, which is then dissipated, providing a smoother and more controlled ride. Panhard rod. Location, a horizontal rod typically mounted transversely from side to side between the solid axle and the vehicle's frame. In the diagram, it's the long, slender rod running from the left side of the axle to the right side of the vehicle frame. Function, the panhard rod's main purpose in a solid axle suspension is to prevent lateral, side-to-side movement of the axle relative to the vehicle body. It allows vertical movement but limits horizontal shifting, which is crucial for stability and handling, especially during cornering. Rear stabilizer bar, anti-roll bar, sway bar. Location, a U-shaped metal bar running across the width of the vehicle, typically mounted to the axle and connected to the chassis via end links. Function, the stabilizer bar's primary role is to reduce body roll during cornering. When the vehicle leans in a turn, the stabilizer bar twists, transferring force from the inner wheel, which compresses, to the outer wheel, which extends, thereby resisting the body's tendency to roll. This improves handling and stability. Stab bar end link. Location, small vertical links connecting the ends of the stabilizer bar to the axle or a control arm. Function, these links connect the stabilizer bar to the suspension components, allowing the bar to transmit forces effectively to control body roll. They provide the necessary articulation for the stabilizer to function properly while the suspension moves. Control arms, trailing arms, link arms. Location, multiple arms, at least two, often four for a four-link setup, connecting the solid axle to the vehicle's chassis. In the diagram, there are blue arms extending forward and slightly upward from the axle. Function, control arms are fundamental in locating the solid axle longitudinally, front to back, and sometimes laterally. They manage the forces, acceleration, braking, and vertical loads transmitted from the wheels to the chassis and ensure the axle remains in its correct position relative to the vehicle body. This specific setup appears to show a four-link system, two upper and two lower control arms, though only lower ones are clearly visible, connecting to the chassis. The green component in the center of the axle is the differential housing, which contains the gears that allow the wheels to spin at different speeds, especially when turning, and transmits power from the drive shaft, not shown, to the wheels. In summary, this diagram effectively breaks down the key components of a solid axle rear suspension system, illustrating how springs, shock absorbers, control arms, a panhard rod, and a stabilizer bar work together to support the vehicle, absorb road irregularities, and maintain stability and handling.